Thank you. Thank you. Hola. Good morning. It's really great to be here at the Congress of the Future. As you heard, my name is Tim Naish. I'm a paleoclimatologist. So that means I study past climate, how the world behaved in the past when the world was warmer, and I use that information to better inform and try and understand how the world may change in the future. Now, before I get started, I want you to do something for me. Will you do that? I'm going to ask you a really simple question. Do you believe in climate change? Put up your hand if you believe in climate change. And you believe it's man-made or human-made? Yes, good. Phew, I was worried you might not. I know Mayissa did a wonderful job. She put up a similar graph, but let's just remind you of the evidence and the things we just shouldn't argue about anymore. The world is warming. The world has warmed by 1 degree since we started using coal, oil, and gas as a cheap source of fuel. And there's the carbon dioxide, atmospheric carbon dioxide curve. It's remarkable, really. If you look at the last 10,000 years, it's been stable, and Earth's climate has been stable, and our civilization has flourished. But 250 years ago, something strange happened. It goes, boom, right up. It increases by 30% at a level that is unprecedented. A level of carbon dioxide we have not seen for 3 million years on this planet. So it's an incontrovertible fact. Global warming is real. It's happening as it's because of us, and we should not waste our energy anymore debating it. However, the debate is around what to do about it. And on this graph here, you can see atmospheric carbon dioxide emissions increasing over the last 40 years. And we've known about global climate change for 40 years. We've known about it since the Rio Earth Summit in 1980 when the first IPCC report came out. So the blue dots are the IPCC reports. And if we'd acted at the time of the Earth Summit, our job would be a lot easier. Even after Copenhagen, when we recognised 2 degrees should be the limit for global warming, carbon dioxide emissions still went up. Even after the Paris Agreement, when 196 countries signed up and said we must keep the world below 2 degrees, carbon dioxide emissions keep going up. So now there is a climate emergency. We now have a very steep path of we have to reduce carbon dioxide in the atmosphere very quickly if we are to achieve the 1.5 and 2 degrees that Mayissa was talking about. We have to be carbon zero well before the end of the century. But I'm here to talk about Antarctica and what global warming means for Antarctica. You know, this is in my backyard in New Zealand, and it's in your backyard in Chile. It's an amazing continent, the highest, driest, coldest, most remotest place on Earth. It is 70% of the world's fresh water and 90% of the world's ice, and if it all melted, we would have 60 metres of global sea level rise. But don't worry, that is not going to happen tomorrow, but it has started happening. And one of the biggest questions we have in climate science today is how fast will this ice sheet respond and melt and contribute to sea level rise over the coming decades, over the coming century. So remember I said 3 million years ago was the last time we had the current level of carbon dioxide in the atmosphere? Well, as I said, I'm a paleoclimatologist, and 3 million years ago, I can tell you that the Antarctic ice sheet melted. The world was 3 degrees warmer, the Antarctic ice sheet melted, and global sea level was 20 metres higher. This is what happens when you leave the concentration of carbon dioxide of greenhouse gas in the atmosphere above 400 parts per million for a long time, for centuries. We will commit the planet to 20-metre sea level rise. Now let's look at what sea level has done since the temperature went up since the Industrial Revolution. And it doesn't sound very much, 20 centimetres of sea level rise. And currently, the rate of sea level rise is about 3.5 millimetres per year. It isn't rising evenly. So when sea level rises, some places get more sea level rise than others because of the way the ocean takes up heat, currents, and climate. And those red-orange colours are places where sea level is rising 5 times the global average rate of 3.5 millimetres per year. And you'll notice those are places where there are very large coastal cities exposed around Asia and also where the Pacific Islands are. And this highlights a real injustice around climate change. The Pacific Islanders, who argued for 1.5 degrees in the Paris Agreement, are the ones at the front line. They're the ones whose homes are being flooded right now, yet they didn't put the CO2 in the atmosphere. Okay, so where is the sea level rise coming from? A third of the observed sea level rise is coming from the ocean heating. So you know if you heat water, it expands. So a remarkable figure is that most of the heat from global warming, 93% of the heat from global warming has actually gone into the ocean. And the ocean is heating and the ocean is rising. A third of the sea level rise is coming from the glaciers, from the Andes, from the Himalayas, from the low latitude, mid-latitude glaciers, and they will largely all be gone in 100 years' time, and they only have another 0.5 metre to give to sea level rise. But those polar ice sheets are big and can cause massive sea level rise, and we really do not understand how they will melt in the future. So the melting of the polar ice sheets is something that, as scientists, we're really trying to understand, and particularly the Antarctic ice sheet. So what I'm showing here is that the Southern Ocean around Antarctica is warming. And a lot of the heat that has gone into the ocean has ended up around Antarctica, which is bad news for the ice sheet, which is flowing into the ocean. So where the ocean has heated the most, the ice shelves are collapsing and retreating, and those are the red dots you can see on the right-hand figure there. And that's because the warm ocean is getting in under the ice sheet and causing it to melt. And potentially you can have a runaway catastrophic melting. And this is because these ice shelves are collapsing. So the ice shelves are the parts of the ice sheet where it flows onto the ocean. These have been heating up because of ocean warming and atmospheric warming. And this is the Larsen ice shelf on the peninsula, within a couple of months, completely disintegrated. And the glaciers flowing that were flowing off the continent into the ocean sped up 10 times. And that causes rapid sea level rise. It's a bit like the buttresses on that cathedral there. They're holding up the church. The ice shelves hold up the ice sheet. If you take away that buttress, the ice sheet collapses, just like a church would. Okay, let's look at the future. So you can see on this graph, sea level was pretty stable, and then at the beginning of the Industrial Revolution, we got our 20 centimetres of sea level rise. And then we have 2 future pathways. Even if we achieve the Paris target of 2 degrees, we will still get 50 centimetres of sea level rise. That's because of the heat that's already in the system. However, if we continue on the path we're on and do nothing, then we will get more than 1 metre of sea level rise, about 1 metre of sea level rise by the end of the century. Now, there's a problem with this picture. We did not include the Antarctic ice sheet. So I was an author on this report. Actually, I was a co-author with Mayissa, the previous speaker. And we did not know enough about the science of the Antarctic ice sheet, so we left it out. That's a problem. Since then, the science has moved very fast, and we're starting to understand the key processes that lead to rapid disintegration of ice shelves and retreat of the ice sheet. And our models are much, much better, but they're scary. So I'll show you some of the new predictions when you add in the Antarctic ice sheet. This study says you can add an extra 40 centimetres by the end of the century. This study, which is a very sensitive ice sheet model, says you can add an extra metre by the end of the century. Whoa! What do you do with that if you're a decision maker deciding whether or not to build something on the coast or whether a community should retreat? These are very uncertain numbers. What the latest IPCC report says is that in a conservative estimate, we will get 1.2 metres by the end of the century if we continue on the path we're on. But there is a chance, and a 5% chance, it could be more. It could be up to 2 metres. So what does this mean for us, the world we live in? And it's pretty concerning. Of the 7.6 billion people on our planet, 2 billion live on the coast. About 1 billion are vulnerable to the effects of sea level rise. Another 2 billion people are reliant on fresh water from mountain glaciers in the Himalayas and the Hindu Kush. So that's half our population are going to be directly impacted by climate change before the end of the century. And poor old Bangladesh, everyone picks on Bangladesh, but by 2050, we can't really help this because it's already in the system. By 2050, the 30 centimetres of sea level rise we're going to get will result in 18 million Bangladeshis looking for another place to live. We thought Syria was a crisis, and it is a crisis, that 2 million refugees, imagine 18 million. So these are the people that will be affected by 2050 in the Asia region. These are some of the large coastal cities and countries, and these are really large numbers. They will experience high tide flooding by mid-century, and the number gets even bigger by 2100. Here's an example of Shanghai. The red is the area at risk from coastal flooding. Here's an example from London. Okay, they do have the Thames barrier, but that will not be fit for purpose in the future. There is a good news story. It's not great news, but it gives us a reason for hope. So on the left, we have an ice sheet model for the future, and you can see the years on top running forward. And you can see on the right, we have an ice sheet model for the pathway we're on. This is a warm, high emissions pathway where we don't really have any policy on climate change. And just within 100 years, you're starting to lose the West Antarctic ice sheet. But the good news is, if we achieve the Paris target, there is a good chance we will save the Antarctic ice sheet, keep the ice shelves intact, and prevent it from melting down. Okay, it's all pretty depressing stuff, isn't it? And I need to leave you with a few take-home messages of hope. And I think from my personal point of view as a scientist who's seen all this science, is it's not too late, but we have to move very quickly. We need our leaders to move very quickly. It is still worth shooting for 2 degrees. Even if we don't get there, we miss it by a bit. 2.5 degrees, 3 degrees, it's a lot better than 4 or 5 degrees of global warming. Now, the other thing is the social and economic issues we are currently all facing, and particularly here in Chile, require us to deal with climate change. So climate action is one of the Sustainable Development Goals. And these other goals, such as poverty, hunger, health and well-being, fresh water, sustainable communities and cities, they all require the climate change goal to be solved. If we don't do that, things are much, much worse. So I think we should be hopeful because of Paris. Even although the last COP was a bit of a failure, this is a strong agreement. It requires governments to get global warming below 2 degrees. And if our leaders are acting slow, people are telling them that's not good enough. Young people, children are out there saying, we're angry with you. We're angry with what you've done to our planet and we want you to act now, and it's starting to have an effect. I mean, we've got Extinction Rebellion. We're seeing the power of people everywhere, and people in Chile know it more than anyone. And in fact, the action you have taken on social and economic equity and dignity is inspirational for the rest of the world. So people power. We should have hope that small countries can help. Just because you're a small country doesn't mean you don't do anything. Again, Chile has shown that. The Chilean government is aiming to be carbon neutral by 2050. It is already 95%. Your country is 95% renewable. I come from New Zealand. I'm very proud of my Prime Minister, Jacinda Ardern, and our government, which has now put into legislation carbon zero by 2050. Now, here's a small nation. That's President Tong from Kiribati in the Pacific Islands. He got all his friends in low-lying Pacific Islands and went to Paris and said, 2 degrees doesn't cut it for us. We need 1.5 degrees. Small nations are making a difference, and they're showing the leadership that big nations will have to follow. Science and technology. It's everything. It's part of the solution. It's part of the energy solution. It's part of the transition to a low-carbon economy. Solar is now the cheapest form of energy per kilowatt hour. Chile is a marvelous example of solar plus also wind farms. Science can also tell us what's going to happen. So even if we don't manage to keep global warming down as low as we should, the science can tell us what is going to happen and what we need to prepare for. So here's Manhattan Island, and they're already spending a huge amount of money on how they're going to defend Manhattan Island because we are going to get some sea level rise. And then there's technology that might be able to take the carbon dioxide out of the atmosphere. Now, I don't think we should count on that, but if it comes, that's fantastic. But at the moment, that technology is at very small scale and is not going to be the magic solution. If we want to live in a safe, sustainable, secure world, the bottom line is we need to leave the carbon in the ground. Thank you very much.